The lizard complex at Cornwall is generally accepted to represent a preserved example of an exposed ophiolite complex in the United Kingdom. The rocks found in the lizard area are analogous to those found in such famous areas as the Troodos Mountains, Cyprus and the Seamale ophiolite, Oman. Lithologies. The lizard comprises three main units: the serpentinites, the oceanic complex, and a metamorphic basement. Since the pioneering work of Bromley and Kirby, these suites have been understood to represent a slice through a section of ocean crust, including the upper level of the mantle, thrust onto continental crust. Serpentinites. The serpentinites are actually the metamorphosed and deformed remains of the upper layers of the mantle. The metamorphosis has in most cases taken the form of ductile deformation and serpentinization. In many cases the rocks have also been subject to varying degrees of later brittle deformation. Pre-deformation they would have been a combination of undepleted mantle in the form of liozolite peridotite and depleted Hartsberg mantle from which basaltic phases had been removed. On the lizard, these two types of peridotite are represented by a heavily foliated orthopyroxene-rich serpentinite and less foliated, less orthopyroxene-rich serpentinite, which is typified by the presence of amphibole. The boundary between these two types of serpentinite can be studied at Kynansko, and geologically represents the boundary between shallow mantle peridotites from which material has been extracted by melting and deeper peridotite, from which no material has been removed. In the area of Ogodar at the northern reaches of Pradanic dunite, a highly depleted peridotite derivative which consists of almost pure olivine, is found. Earlier theories, most notably the BGS publication Lizard and Amphimonade, that summarized thinking up to the point of publication, proposed that the serpentinite body represented an intruded mass of ultramafic material. They believed that the foliations were the result of mass flux within the cooling magma body, and that the different types of serpentinite were the result of an igneous cooling alteration rim. Oceanic complex. The oceanic complex consists of the Crucigabbro, locally intruded by a suite of dolerite dikes, and a number of schists, split into two broad groups, hornblende schist and mica schist. The hornblende schist, found in contact with the serpentine mass directly to the north and to the south, is the metamorphic remnant of basaltic intrusives into the upper crust. It is typified by a schistose texture and visible crystals of black or dark green hornblende. Structural studies of the hornblende schist indicate that it has been subject to at least 3 stages of deformation. Folding of the schist at Housel Bay indicates that the formation was also subject to more than one subsequent stage of shear stress. On the southeast tip of the lizard, the hornblende schist is interbedded with pale yellow, green veins and pods of epidesite. These bands can extend laterally for many meters and lie in line with the schistose foliations of the surrounding rock. It is unclear what the provenance of these bands is, but theories include that they are the remains of volcanic ashfall during the deposition of the schist protolith, or the calcic remains of thin beds of ocean floor material deposited during less active periods of emplacement of the protolith. Chemical analysis of the schist draws parallels between it and mantle-derived material found at mid-ocean ridge and back arc settings. Basement. The basement comprises a group of schists and gneisses of the Old Lizard Head series and the Man-of-War gneisses. The Man-of-War gneiss is interpreted as a sequence of metamorphosed igneous rocks, possibly intruded as part of the breakup associated with the formation of the ocean. UPB dating gives a late Cambrian age for both the Man-of-War gneiss and for intrusions cutting early fabrics in the Old Lizard Head series. series. Structure. The current outcrop pattern of the various units of the lizard complex is mainly controlled by Carboniferous age normal faulting. The earliest structures seen in the ophiolitic rocks are steeply dipping foliations thought to represent deformation in lithosphere-scale shear zones, associated with continental breakup in the early Devonian. Locally thrust contacts can be seen showing evidence of northwestward movement between parts of the ophiolite and between the ophiolitic rocks and the metamorphic basement. It has been suggested that the cairnic gneiss was formed by partial melting during the abduction of the ophiolite onto the continental crust. Although an earlier stage of hot emplacement is not ruled out, it is now generally accepted that in the final stage of emplacement, during the Variscan orogeny, the ophiolite was relatively cold. The northward dip of thrusts at the base of and within the ophiolitic rocks is interpreted to be caused by rotation of initially south-dipping thrust planes due to the dominantly south-dipping post-Variscan extensional faults. Timing. The formation of the oceanic crust found at the lizard, its abduction and final emplacement are thought to have happened over a short period of approximately 35 Ma during the Devonian period. This is based on UPB dating of zircons from various parts of the complex.